Hey everybody, this clip that you're watching right now is part of a bigger lesson on multiplying and dividing rational expressions. What you're going to see in the clip is some introduction examples to deal with some of the basics with the theory and then some of the mechanics of going through and multiplying and dividing fractions that contain variables. I hope the clip helps. Good luck. What you'll notice in problem 2 is that's going to start to look like the normal sorts of problems that we're going to address. So what I would like you to do is to work your way through 2A. So copy that question down and then get a full simplified solution. Okay, pause it now. Okay, we're back. So my suggestion to you sometimes, and I'm going to really mark up my problem here, but my suggestion to you is I think it can be tough to go like, okay, so a 5 divides into a 5, and then, okay, so then I can divide out a 4 from both of those, and then I've got B's here, and then I've got, and all of a sudden, it can get so confusing with all these slash marks in your original expression that my recommendation to you, reduce your coefficients. That is, treat this problem exactly as we did and imagine that there were no variables. So I could divide out a 5 from 5 and 15. I could then divide out a 4 from 8 and 12. I can then divide out a 3 from both those 3's. All my coefficients have been reduced. My recommendation to you is put in one middle line. Multiply your fractions now. Notice we're going to have a 1 times 1 on top as my coefficient, but then I'll have an a squared times a and a b times b. On the bottom, I have my 2b squared. And just by putting that one line in, I think your risk for mistake is gone. That we should be good now to see that our b squareds are going to divide out, and that's going to reduce to an a cubed over 2. Nice. And so we know that we're all done. No, and I'm hoping that we can remember back to last time that we have to deal with our restrictions. So we look back to the first factored form. There's where everything is factored. Tops and bottoms are all one term. And I notice that the only restriction that I need to tack on is that b cannot equal 0 for all of those expressions to be equal. There we go. So I think a nice, easy warm-up question for us. Now I'd like you to take a look at b. So we're going to jump our way into b. And I think you can just end up making one really bad mistake. So let's address it right off the bat. You take a look at mine, and if your instinct is to, hey, I've got a 10 there, and I got a 4 there, I just want you to notice that what I just crossed out, I can't do that. Those aren't factors. I'm dividing individual terms, and I can't do that because there was not a common factor of 4 in every term or a common factor of 10 in every term. So I think that's really your only really bad mistake. We're going to slowly kind of build up well, maybe not even slowly. We're going to build up an instinct that when we see multiplying fractions, we don't really want to multiply. Take a look on top. You're going to take a linear expression, degree 1, and multiply that by a quadratic expression, degree 2. Well, we should be pretty good to see that our next term, if we just multiplied, is going to be a 2x cubed. And then we're going to have the rest of that as we collect like terms. Well, do you know how to factor all your cubics? No, you do not. And so by multiplying, we actually may have just created a problem that we do not have the means to solve. So I want to make sure that our first instinct is not to multiply, but that it's to do what the problem said. simplify. So let's look and see, can we reduce each individual fraction, or can we do a little cross-reducing right off the bat? So in order to do that, that instinct I spoke about is going to get built pretty quickly. Our first step always should be to factor. Let's see what makes up those expressions. So what I'd like you to do is pause the video now. Let's factor everything and see if we can reduce. Okay, pause it. Okay, we're back. So I take a look at my first line. I can common factor out a 2 on top. Bottom is a simple trinomial. I can factor that. My next fraction is a simple trinomial, so I can factor that one as well. And on my bottom, I've got a difference of squares, so I can factor that. So notice, all my numerators, denominators could factor. Now I'm going to look to the inside. I'm going to see what makes them up. Is there anything I can reduce with? So I take a peek at that, and I notice I have a common factor of x minus 2 on top and bottom. I also notice that I have a common factor of x plus 2 on top or bottom. Now I'm really close on the other ones. I've got an x plus 5 and an x minus 5, but those aren't the same. What you see on your screen is the most dividing out that I can do. That is the most simplifying I can do. So what do we end up getting to? Well, that means that I'm going to have a 2 times an x plus 5 over, and on my denominator, I'm going to have my x minus 5 times x minus 2. Now, I know that the instruction says to simplify, but we're going to give you kind of an expectation, a pattern to be able to work through. I need you to know that if I tack on my restrictions on x, that is the best form for me to leave my answer in. I want to explain why. I want you to notice that, yes, I could expand the top and I could expand the bottom. So I could end up writing 2x plus 10 over x squared minus 7x plus 10. However, I want you to notice that that blue form isn't any more useful. Like if I asked you to go and do something with the blue, wouldn't you just have to refactor it anyway? So we don't expand unless we know that we can simplify our expression further. And I can tell in my last red line that there will be no more simplifying because there are no more common factors. So it's nice. We leave it in factored form. Okay, the only last thing to do, tack on those restrictions. I look back to my first factored form and I notice that my x value can't equal 5. It can't equal 2. But I also notice it can't equal negative 2. So I have my plus or minus 2. And by the time I look at that factor, I notice I already took care of that earlier. Nice. What you have in that final red line, there's our final expression. There's our final solution. Okay, hopefully that one wasn't too bad. You notice that really it comes down to how well do we factor. Once we factor, going on the hunt for common factors becomes a pretty straightforward process. Okay, let's keep it going for today. In order to do that, we just got to talk about a little bit of theory first.